This PowerPoint is for Chapter 8 for 1105. In Chapter 8, we are going to be learning about statistical functions in Excel. In particular, we're going to look at analyzing statistics and also statistical functions to analyze data for decision making. Now, statistics involves analyzing a collection of data and making inferences to draw conclusions about a data set. So you have a data set. Statistics is about finding sort of relationships between the data to make meaning out of it. So for example, when you purchase a car, you compare the average miles per gallon, the MPG, amongst different vehicles, right? The automobile manufacturer has conducted multiple test drives and recorded this MPG under various driving conditions and then calculated the MPG statistic based on the average performance. In this chapter, you're going to learn how to do SUMIF, average if, count ifs, sum ifs, average ifs, and count ifs. You've already done sum, average, min, max, median, and count, right? So it's sort of like that with a little bit of a twist. You're also going to learn rank, percentile, and quartile. So using conditional math and statistical functions. Like I said before, you've already used sum, average, count functions, right? So when you use these sum, average, count functions, Excel calculates the respective total, the mathematical average, and the number of values for all the values in a range specified by the function's arguments. So the math and statistical function categories contain related functions. So it looks at sum ifs, or average ifs, or count ifs, or sum average ifs, count ifs, that perform similar calculations, but based on a condition. So only the sum of the data if this data meets a particular condition. Okay, so this function is similar to the if function, right? So instead of delivering a value of true or false, like in if functions, these functions then perform a specific calculation when specified conditions are met. So the SUMIFs functions are math functions, and they're located in the math and trig in the function library group. The average ifs and count ifs functions are statistical functions, so they'll be in the statistical functions group. So let's watch the video tutorials to see where you can find these functions and how to use them. And when you're done, please come back to the tutorial, to the PowerPoint. All right, so moving on, we're going to look at calculating relative standing with statistical functions. Often people analyze a data point compared to the entire data set. For example, a professor might want to rank students in chemistry class, or a medical doctor might want to identify a diabetic patient's blood sugar levels based on what quartile they fall in. So the rank, EQ, percent, rank, quartile, and percentile functions are used to analyze data in this way. Okay, so the rank functions, there's two of them. There's rank EQ and rank average. Rank EQ function identifies the value's rank within a list of values. It omits the next rank when tie values exist. Okay, so for example, if the range of values contains duplicate numbers, for example, if there is 44,966 in two different cells, both values then get the same rank. For example, if that's 8, then they both get 8. And then the next value, that's, like 4590, would get 9, would get skipped, and the next value higher would get the ranking of 10. Okay, so 9 would be skipped altogether, and then the next value would be 10. So the rank average, though, identifies the rank of the value but assigns an average rank when identical values exist. So if these values are the same, 44966, instead of getting an 8 and skipping the 9, they're each going to get 8.5, the average rank of between 8 and 9, instead of rank 8 and then skipping 9. All right, so please watch the video tutorial on how to do the rank function, and then when you're done, please come back to the PowerPoint. Next, we look at the quartile functions. A quartile is a value used to divide a range of numbers into 4 equal groups. The quartile.inc function identifies a value at a specific quartile for a data set, including quartile 0 for the lowest value and 4 for the highest value in the data set. Now, the quartile.exe function is similar in that it returns a value at a specific quartile, but it excludes 0 and 4. These functions contain 2 required arguments, the array and then the quart. The array argument specifies the range, right, of the values, the range that you're going to look at. And the quart argument is a number that represents the specific quartile. Okay, so the argument value here, so the 0 for the quart would be lowest value in the data set, identical to using the minimum function, the min function, allowed in the quartile.inc function only. Then you have the 0, it's the first quartile of the data set. It identifies the value at the 25th percentile. Then you have the value of 2, the second quartile or median value within the data set, identifies the value at the 50th percentile. Then you have the number 3 value, third quartile of the data set, identifies the value at the 75th percentile. Then you have number 4, the fourth quartile, the highest value within the data set. So this is identical to using the max function, and it's allowed in the quartile.inc only. Next, we have the percentile functions. The percentile.inc function identifies the kth percentile of a specific value within a list of values, including the 0 and the 100th. So when you think of inc, think of inclusive, right? Includes. Okay, therefore the INC, inc. Anyway, college, for example, here, the example that the textbook gives you, the college admissions office identifies the college applicants' percentiles to determine which candidates to admit to their college, right? So they might have a policy to admit only the candidates who fall within the 80th percentile. Okay, so that's a case where this function would be used. The percentile.x function also identifies a value at a specific percentile. However, it excludes the 0 and the 100th percentile. So the percentile functions contain 2 required arguments, like previously, quite similar to the previous one, array and k. All right, here I would like you to pause the video and go to your tutorial videos to watch the tutorial and then come back to the PowerPoint when you're done. So attempting to make decisions based on data sets with lots of entries can be overwhelming. Descriptive statistics provide the tools that help us analyze and describe these large data sets into pockets of manageable and useful information. So remember that while descriptive statistics like average and quartile are useful in defining the characteristics of a specific data set, they're only calculations that describe the data, and they don't provide insight that's applicable into data outside of the data set. Okay, you can only describe the data that you're looking at, that you're finding, descriptions about, like relationships between those different data within the set, but not something that's outside of it. So if, for example, a survey of high school teachers' opinions on dress code in Ohio would not provide any insight into high school teachers' opinions in Arkansas. So I guess that's a textbook example. A better example would be a survey of high school teachers' opinions on dress code in Vancouver would not provide any insight into high school teachers' opinions in all of BC or all of Canada. It's only for very specific, only Vancouver, perhaps even only one school in Vancouver, right? So you can't apply what you have learned here, the description here, to a bigger kind of population outside of your data set. Okay, so next we're going to learn about statistical functions like variance, standard deviations, correlationships, and frequencies to measure the central tendencies of data sets. Okay, we're going to learn about how calculation methods differ when you're dealing with population and sample data. Okay, so when you're measuring central tendency, what are we talking about? The average if quartile, and rank average are all tools to measure central tendencies. So frequency, variance, standard deviation, and correlationships help to define the shape and variation of a population or a sample. But first, let's talk about, I've mentioned population and sample a few times. Let's talk about the difference. A population is a data set that contains all the data that you would like to evaluate. A sample is a smaller, more manageable portion of the population. For example, all the educators in the state of Pennsylvania is an example of a population, so all of them. And if somehow you're able to get statistics or get numbers or data about all of the educators in the state of Pennsylvania, then that would be great. That's the whole population. But if you're only able to reach like 10% of them, then that is a sample, okay? A sample is like part of a population. Sometimes it's not easy to test the whole population, so you get a sample, like a group of people, of the subjects within the population. Okay, so next we look at standard deviation and variance functions. Variance is a measure of a data set's dispersion, such as the difference between the highest and the lowest scores in class. Standard deviation then is a measure of how far the data set is spread around the mean. So if you have a mean, and how far is that data, are those marks, are those scores spread out around that mean? It's also referred to as this kind of symbol here when using statistics. If calculated manually, the standard deviation is really the square root of the variance. Okay, so again, the standard deviation, which is a measure of how far the data sample is spread around the mean, is the square root of the variance. Variance is the measure of the data set's dispersion, which is the difference between highest and lowest scores in class. All right, so measuring variations within the data set. Standard deviation and variance are the two most popular tools to measure variations within a data set. So when you're working in descriptive statistics, the statistician can utilize data from the entire population or from a portion of the population called a sample. Excel offers a variety of functions for these calculations based on the use of a sample or population. Okay. Next, we have variance. So the variance of a sample is the summation of the squared deviations divided by the size of the sample, okay, which is n minus 1, in which n is the number of data points. Okay, n is a number of data, number of data points, number of numbers that you have. Okay, the variance describes how the data points compare to the mean. For example, a large variance indicates that the data points are spread further from the average, where a small variance can indicate that the data points are very close to the average. Okay, so we've already talked about standard deviation. Let's take a closer look at it. The standard deviation describes like I said, the same data spread as the variance, but the calculated value uses the same units of measure as the original points, and it's easier to understand. So this value is calculated mathematically by determining the square root of the variance, okay? But the good news here is, after I've talked about all those past few slides, the good news here is in Excel, these functions are just as easy as using a sum function. You really just have to type in the function in Excel. Okay, so here I would like you to pause this PowerPoint video and go to your tutorial and practice or watch the tutorials and see how these formulas are entered. Next is the Quartile function, which is short for correlation coefficient. This function helps to determine the strength of a relationship between two variables. Okay, so when used to compare data sets, the function is going to return a value between -1 and 1. And the closer the value is to 1, the stronger the relationship is. I would like you to pause this PowerPoint and go watch the video tutorial on how to use the correlationship coefficient function. Next is the frequency function. The frequency function function is a descriptive statistical function in Excel that determines the frequency distribution of a data set. So the frequency distribution is a meaningful descriptive tool because what it does is it determines how a set of numbers appears within a data set. For example, you might want to determine how many students' GPAs falls within a specific range. So the frequency can determine how many students earned A, B's, and C's. And it returns the frequency of the numerical occurrence in bins. So you have an A bin, B bin, and a C bin, and how many in each of these bins. Okay, so bins are data ranges in which values can be categorized and counted. So for example, when evaluating GPAs, bin 100 to 90 would contain the number of students that received an A. So there's the frequency versus the countif. You might be asking, isn't there already a countif function? So what's the difference? Okay, the benefit of the frequency over the countif function is its ability to evaluate an entire data set in one calculation. So also, unlike other Excel functions, you do not simply type in the frequency function in a cell and press enter. Okay, instead you have to select the cells first and then put the frequency function, type in the formula, and then press Control-Shift-Enter, and this returns the calculations results for all the bins defined in the function. So countif is only looks at if it meets one criteria. If it's between 90 and 100, then count how many. But using the frequency, you can set numerous bins, okay? And then just using that one frequency function, you can calculate all of it all at the same time. So here I would like you to again pause the video that you're watching right now and go to the tutorial video and watch the one on frequency, please. Next, we look at inferential statistics. Descriptive statistics help to define characteristics of a population like mean, standard deviation, and variance, and so on. Other times, the population is too large to acquire every data point needed, so samples must be used. For example, if you want to look at all of the Canada's population, everybody that lives in Canada, that would be too large of a, too many data points, right? And that's not feasible. It's not that's not reasonable to get. Then you need to have a sample of it, okay, like part of the population. So using samples, the limitation of dealing with samples is that they don't contain all the information available. So depending on the sample set selected, the relationship between the sample set and the entire population may not be very strong. Okay, so for example, if you want to, if you want to find out something about all of Canada's population, and then in your sample set, you only have, people who are ages 20 to 25. So then this sample set is not representative of the entire population, right? Because it doesn't represent, it's not very strong, it's not a very strong relationship, okay? So inferential statistics helps you analyze the differences between groups and relationships within groups of data. So they can be applied to samples to make more informed statements about a population within a certain margin of error. Okay, so before you do the next step, you need to first load the add-in analysis to a pack. First, you'll be required to load this to a pack prior to performing any calculations that we're going to be doing. So please watch the tutorial on how to do this, how to load this add-in, and then you can continue watching this video when you're done that. Next, performing analysis using the analysis to a pack. So after you have watched the tutorial on how to add this analysis to a pack, you're ready for the next few slides. So the analysis to a pack offers 19 tools that fit a variety of needs across all professions. In Excel, there are alternate options to many of these tools, like the frequency function versus the histogram summary in the to a pack. So the benefit of using the analysis to a pack versus the corresponding function is that the to a pack would generate reports while the function equivalents only return values. So in one case, you only get the values that are returned to you, but the toolpack gives you reports. Okay, so we are going to be performing analysis of variance, Anova. So in statistics, it's common to compare the means between two or more sample groups of data. For example, comparing test scores from cross-sectional sample of multiple high schools in the same district. Excuse me, or comparing test scores in a time series sample over a period of years from the same high school. So different sample sets, same test. Excuse me. A common tool to compare these samples is analysis of variance, also abbreviated as Anova. So Anova is a statistical hypothesis test that helps to determine if samples of data were taken from the same population. In practical use, it can be used to accept or reject a hypothesis. There's no one function to calculate Anova in Excel the way it is without the add-in. However, using the analysis toolpack, you can create an Anova report quite easily. So there's three types of Anova calculations. There's single factor, two-factor with replication, and two-factor without replication. So the report, what you end up with is the report, and the summary portion of the report provides a basic descriptive statistics of each of the groups that are analyzed. So the Anova portion of the report breaks the data into two sets, between groups and within groups. The Anova analysis within groups measures the random variation. Anova analysis between groups measures variation due to differences within the group. Okay, so here is the Anova summary report. And this full name explains the abbreviations that you'll see in your summary report. So you have the SS, which is the sum of squares, which is the sum of squares of the data points in the sample. You have the DF, which is degrees of freedom, and it's the number of data points in the sample minus 1. You have the mean square, which is MS, which is the means of the sample square. We have the F ratio, which is equal to the mean square between mean square within. And then the p-value, which is a probability, meaning the probability of the population being similar to the sample. Okay, and then you have the F-crit, which is a critical value of F, and this is used to determine if the F-test is significant. Here, I would like you to pause the PowerPoint video and watch the tutorial video on the Anova. Next, we move on to the covariance. Covariance is similar to correlation. It's a measure of how two sets of data vary simultaneously. It's calculated by taking the average of each product of the deviation of a data point. So we have the covariance P and covariance S functions. Okay, there's two of them. Covariance P and covariance S functions can calculate covariance, and there's also a covariance reporting feature in the analysis toolpack. While both analysis toolpack and the covariance functions will return the covariance, the analysis toolpack also calculates the variance in the output of a pre-formatted report. So remember, I talked about it before. Although Excel has some of the same functions, it's better to do it in the analysis toolpack because it gives you a report. So for example, you might hypothesize that the more days of school missed by a student, the lower his or her scores. The correlationship function would return a numerical value that analyzes the strength of the relation. The covariance analysis will provide a matrix that shows how the data sets change together. So it actually shows the relationship. The covariance just shows you the strength of the relationship. So positive covariance indicates a positive relationship, and a negative value indicates an inverse relationship, and a 0 value indicates no relationship. Okay? I would like you to pause right now and please watch the video tutorial and come back to the PowerPoint when you're done. Next, we're going to look at how to create a histogram. So a histogram is a visual display of tabulated frequencies. There are several ways to create a histogram in Excel, and the easiest way is using the analysis tool pack. So creating the histogram is actually similar to using the frequency function because it requires bins to tabulate the data and will return a frequency distribution table. Now I would like you to pause the PowerPoint again and please refer to the video tutorial on histogram. When you're done, you may come back to this PowerPoint. Next, we look at creating a forecast sheet. This feature extrapolates information based on given historical data and generates a worksheet that details the predictions. It forecasts, it predicts. For example, if the test scores were tracked over the years as they compared to average teacher salaries, the forecast sheet will generate a chart and corresponding table to give a future forecast based on given data. It doesn't just look at data that has already happened, it can predict and forecast future data. Okay, the worksheet provides information with default confidence level of 95% and gives the user the option of setting the start values, end values, and the chart type within the forecast. And I would like you to now stop the video and watch your last tutorial video, and you are done for this chapter.